How are we doing on these? We get these done? At least these first four here.
I was barely starting 41.
You're about to start 41.
Yeah.
Did you get these tables?
Yeah.
All right. So how would you describe this change here?
I mean,
I'll give you this one right here. This one's +1.
the y is multiplied by 4.
The y's are multiplied by 4, right? Each time we're multiplying by 4. And I'm looking for something that looks like an f of x equals c a to the x. Running out of room here. So you need to know that it multiplies by 4. The other thing we need to know is the y-intercept. And if I know those two things, I should be able to fill out this formula. So what is my c value?
2.
It's the 2 right there. What is my a value?
4, sorry.
The what?
4.
Yeah, okay. And that's my formula. I have a 2 as my c value and have a 4 to the x as my base. And yeah, it's recording me. Questions about this one? So C, I think I said it, is like the y-intercept. It's where it's starting, right? It's your initial value. The other thing is the A, that's the rate of change. And so we're multiplying by 4 each time. And so that's going to end up being my base. So every time I increase my x by 1, I'm multiplying by another 4. Okay.
Excuse me, in this we have the f of x is equals to 2 times 4 power of x.
Yeah, that's it.
Yeah, okay, thank you.
Okay. And the next one, 15. Someone was Carson. Did you get this one?
I was kind of confused like going into it, but after you just did that problem, I kind of get it a little better now. So the rate of change on the bottom is it's being cut in half. So times half, I guess, would say.
Yep. Each time we're multiplying by a half. Let's do that for my multiplication. You might say dividing by 2, right? That might be another thing someone might say. But what we really want is the multiply by half. That will get you your base probably better. And then the other thing we need is what is the y-intercept?
8.
Yeah. And so what is my formula here? F of x equals
8 half of x.
half to the x, right?
To the x, okay.
Yep. That's it. CA to the x. So f of x equals 8 times 1/2 to the x power. Questions about these two?
In this case, teacher, which one is the 14 is the exponent function and the second one is the linear function?
The second one.
Because they are asking which one is the exponent and which one is the linear.
This comes from a longer list of problems, and so what they're saying is find either linear or exponential. It could be one or the other. What they want you to do is check it and see whether it's linear or exponential. And so when we talk about the change in the y, how are you going to describe that change in the y? If we go from 64 to 32 or from 32 to 16, each time
decreasing.
It's a what?
Decrease, like it's go down.
It's decreasing by what?
By half, 64
by half, right? And so if you're
Yeah.
saying it's decreasing by half, it's decreasing by a factor of a half, right? We're multiplying it by a half.
Mhm.
And so since we're multiplying, the operation here is multiplication. And so whenever I multiply or divide, multiplying is just dividing is just multiplying by the reciprocal, right? And so if I'm multiplying or dividing, that's indicating that this is exponential. If it was like,
Adding or subtracting is linear.
yeah, if it was addition or subtraction, that would be linear. So if I have like 4, 6, 8, 10, 12, right?
Yes.
Each time I'm adding 2, right? And so something like this would be linear. So you have to look at what the operation is. How is that y increasing or decreasing? I'm glad you brought that up because it totally says linear there and they gave you no linear. Yeah. But it's supposed to be for like exercises 13 through 22. So I bet if you go look in your book, some of those other ones are probably linear. They probably got them mixed in.
So if I'm not mistaken, 14 and 15 are extra functions.
They're both exponential functions. Yeah, that's it. And that's because we're multiplying or dividing. If we were adding, then it would be linear. 41. Did we get this far? I bet y'all could tell me this anyway.
I'm not sure. I tried working on it, but I'm not sure if I did it right.
All right, f of x. And I'm looking at something that looks like f of x equals ca to the x. And so I want to know what my c value is. I want to know what my a value is. So if I read this, there are initially 5,000 bacteria, and the sample doubles in size every hour. So what is my c value?
I think it's 5,000.
Bacteria.
It's the 5,000 bacteria we're starting out with. What is my a value?
3 hours.
No,
How much does this change?
Oh, it doubles.
double.
It doubles.
That'd be 2.
So yeah, my base is 2 to the x. So your c is like your y-intercept. Your y-intercept is like kind of like saying your initial amount, the starting amount. And so we had that sort of thing happening when we were doing linear functions, right? We have the y-intercept as our starting amount. The other thing here, we have a starting amount and we have a rate of change, right? C is my starting amount, A is my rate of change.
Teacher, here our x is one, it's the hour, it's the time, right?
Yeah, so I think it says define x. I probably didn't do what the instructions say, right? I got sneezed, it's coming. Maybe.
What did you say? Sorry.
Sorry. X is the number of hours, right?
Here are the hours is 1 hour,
And then f of x would be what? The number of bacteria?
10,000. Like
So
like
this
the-
would be the number of bacteria total. If we wanted to do in thousands, we would have to like get rid of these thousands here.
like 10 power, no, 10 power of 3. Teacher, my question here, excuse me, my question, it's about the x. Our x, it's the number of hour. The time
That's-
when we have 2 power of x, it's going to be 2 power of 1, and then 5,000 times 2 is 10,000 bacteria, right?
Yeah, so if they ask you how many bacteria you have after 1 hour,
When I say you have 10,000 bacteria.
yep.
Okay, thank you.
And 43 says in 2015, a house was worth 200,000 and its value decreases by 5% each year thereafter. This one might be a little bit trickier, but with still the same formula. f of x equals c a to the x. I feel like the c is kind of hitting you right there, maybe. Who's next? Fidel? What's the starting value? What's the c value here?
So the worth of the house would be 200,000.
And this is the part that might be a little tricky. If we're decreasing by 5%,
Right.
what is the rate of change there? So I'll give you maybe a little hint. If we take 100%, we're taking 5% of it away. What are we left with?
So 95.
Yeah, so each time it's going to get multiplied by a factor of what?
You mean 95?
The 95%.
But before we are going to go to go why you put 900 no 100 and the minus 5, it's going to be 95. I don't understand here the process. Sorry.
Okay, so we're decreasing by 5% each year. I can elaborate a little bit on this. We're starting with 200,000. We're decreasing by 5% each year. Let me stop sharing this and so I can share it from here. I share a whiteboard.
Thank you.
So let's do year one just to see like how this thing is happening. So if we take 200,000 and we're starting off with one of those 200,000, and I'm going to subtract it by 5%, right?
Mhm.
But I'm going to subtract it by 5% of what?
Of the total.
It's the 200,000, right? And so I'm taking one of those 200,000s and I'm subtracting a whole nother 200,000 or 5% of it. What I actually have, we can use maybe some factoring to see it, but we have a 200,000, we're subtracting 500% of it. What we actually have is 1 minus that 0.05. So what I'm actually doing is 95% of the 200,000. So if I'm decreasing by 5%, it's the same thing as multiplying by 95% of that thing. This is sort of like when we figure out like prices as well. If I'm taking 20% off of a price, I'm paying 80% of the price of that object, right?
Mhm.
This is like, kind of like the same thing. I'm decreasing by 5%. That means each time I'm 95%ing that object. So this is what, home value. So I believe it was like 200,000 and 0.95 to the X was our final formula. And so this is your final formula. Each year, you're going to take 95% of that thing. It's decreasing by 5%. There's a really common problem if you look at like shifting reference values, what they call it, percentages. People will do the wrong thing. If I take 20% off each year, it's not the same thing as taking. If I take 20% off for 3 years, it's not the same thing as taking 60% off the original price, right? Each year you're shifting the number and it becomes not quite 60%. Any more questions with these four? Yeah, stop sharing that. Let's go back to this one. All right. So the next ones I want to do, I want to go through these. I think there's like 4 graph ones. Let me see. We're doing, I believe, what we just did 43, 55, 61, 70, 75, and 79, I believe. So everything up to 79. Basically, these are all the graph problems. So let's look right quick. I talked about this. I want you to make a T-chart with these basically, right? Get about 4 points of these things and sketch a rough graph. I'm not expecting the best. If I'm being honest, I'm not expecting like Picasso here or something, right? I'm not expecting the next super detailed oriented graph, but I want you to have some idea what these look like. 70, find the formula. 75, mix and match. 79, they give you a graph and they ask you about these transformations. I'm probably not going to graph a bunch of stuff in class because it takes a lot of time. You should know how to graph them. You should be able to explain what to do. You should be able to explain that transformation that's happening. Okay. And then the last few are word problems. Those are going to take a minute, but I want to get through the graph ones basically. So I believe that is everything between 55 and 79. So 55, 61, 70, 75, 79. I know those are quite a few, but one of those is mixing and matching, right? Any questions before I open up the rooms again? Okay. And so I know I'm like probably like really pounding on some kind of drum here, but when we were doing those exponents sort of things, I was like, hey, y'all should probably study this stuff because it's going to come up again. And so all those exponent rules that we're using, they're coming up when we do exponential functions again, right? We're doing exponential stuff today. Guess what we're about to start doing? We're about to start doing log stuff. And how well you do in logs is probably going to be dependent upon like how well you're doing in this sort of stuff. It's building upon this. We're going to define logs as kind of being like the opposite of exponential. And so I really want to like encourage you, like you're here, you've gone through all this class. We have like 2 weeks left. Like continue to be active, continue to try to learn this stuff. Just a little bit of word of encouragement. Y'all are here. So y'all did something correct so far. All right, I'm gonna open up the rooms.
And enough. That's why I'm like, I'm lost. Okay. So let me try it.
What is 3 to the minus 1? That goes back to those exponent rules.
1/3.
It's 1/3. Right, I think minus 2 would be 1/9.
Yes.
I'm running out of room up here, but this would be 1/9. 0, if I throw in 0, 3 to the 0, that should be
1.
well, 1.
Oh,
That should be the thing that takes you 1 second to figure out, hopefully. Anything to the 0 power is 1.
Okay.
3 to the first power is
3.
3, and then we get what? 3 squared is
9. 27.
all right. And if we're graphing this thing out, I know I'm gonna go like, I hope you do a better graph than I'm doing here. I'm just gonna like kind of plop something down here just to get the kind of general shape. Comes through at 3 here. And it's gonna grow really quickly. Like it's gonna go 3 at 2, it's gonna be way up here at 9 already. If we come to the left side, it's gonna keep shrinking and shrinking, shrinking. But no matter how large we get, right, it's never going to cross 0. We think about 3 to the, I don't know, 1,000 power, minus 1,000 power or something. It's just 1 over something really large, right? Negative exponents are just flipping them over 1. And so we're going to get a really, really small fraction the closer we go, or the further we go left, the smaller our fraction is going to be. But it's never going to hit 0, right? It's going to kind of level out right there and never go past that 0. It'll keep going down.
But here, teacher, if in the exam, we are going to have a little bit of difficulties to draw the graph because of the numbers or I don't know. To be very accurate.
Well, hopefully on the exam you have like a graph that you can draw this on or something, but it should go through 2.9. We've done T-charts and stuff like that. That's old.
Like small, just 2 or 3 numbers. Okay.
Yeah, that's old. That's old news. Yeah. So as long as you get like, I don't know, probably 4 points on these things.
Because if we draw 3 to 27, it's a lot. 1 over 27, it's too small number.
Yeah, I mean they get really hard to sort of draw going to the left, right? Because we're getting smaller and smaller
Yeah.
fractions. Yes, I'm not expecting it like to go through every point exactly accurately, but as long as you get like 3, probably 4 points on here, just to be safe, get a pretty good idea of what this thing looks like. And so this is exponential growth. That means our base number was over 1, right? Our base number here is 3. Anytime we have a base number that's over 1, anytime we multiply by a number that's over 1, right? It should get larger. Anytime we multiply by a fraction, what's going to happen? So I think that's the next one, right?
So small and squeaky.
Yeah.
It's like the parabola.
So f of
Open,
x,
it's going to be open large, like very large, and when it's
we get 2 and 1/4 to the x.
Yeah.
Josh, did you do this one?
So for my T chart, I got -2, 32, -1, 8, 0, 2, 1, 0.5.
A half. Yeah, it's
Yeah.
a half. Did you do any more numbers or just those 4?
I did those, and then it was supposed to go like,
We get an 8th here, right? We do
Yeah.
2. Each time you should be multiplying by a quarter. So there are a few different ways to do this. If you want to plug in the numbers, that's one. I might start just by doing like 0 and throwing in a 0, and then I see 1/4 to the 0 is just 1, and we're doing 2 times 1 gives me 2. So I know each time I'm going to multiply by a quarter. So if I go this way, you can also just start at your intercept and then just multiply by a quarter going this way, right? If that way is multiplying by a quarter, this is multiplying by 4/1, the opposite, dividing by a quarter. So multiplying by 4 would be going this way. Go the opposite way. That might be a little confusing maybe, but
I have a question.
yeah.
Okay, so I understand to make a chart, the T chart, I understand that. So in so many words, if I'm not mistaken, how you said that since it's a fraction, we should just kind of start at 0 instead of, because like if I make the exponent a negative, we had to flip that fraction and all of that. So right?
Yeah, so like if x is a -1, we're doing 2 times 1/4 to the -1. That's the same thing as flipping this. So we're doing 2 times 4.
Oh, okay.
If I do it to the -2, I'm doing 2 to the 4 squared, which is 16 times 2, which is where he's getting this 32 from. So yeah, I guess I should plug in the negative exponents because those are kind of weird, having negative exponents with fractions. So. Same thing here. If I do plug in 1, right now, if it's a positive 1 up in here, I'm not doing all this. I'm just multiplying this by 2 1/4 is a half. So we plug in these x values, we evaluate this function, and now I want to do a really basic sort of graph. -1 is way the heck up here at 8. 0 is like right around here at 2. 1 is at 1/2. And then we keep getting closer and closer to the axis sort of thing happening here. So this should look like the other thing, but sort of flipped, right? Now we're doing exponential decay. It's decreasing. And I talked a little bit about why it might be decreasing, but it's decreasing because each time we're multiplying by a quarter, right? So if we get a base that is between 0 and 1, if we multiply by a fractional amount, we're making that thing smaller. And so if we go left, it should be shooting off to like sort of infinity happening here. If we go to the right, it should be leveling out like right at 0. It's not going to cross that axis. Questions about these graphs?
Could you explain one more time how you got 32?
How we got 32? So like 2 and 1/4 to the -2.
Yeah.
I want to take care of that negative exponent first. And so how do I take care of this negative exponent?
Flipping it.
I flip it. So instead of 1/4, this is what? 4/1 or just 4? So we're doing 2 times 4 squared.
Oh, okay, and then it'll be 2 times 16.
Yep. And I get you the 32.
And then we just did the same thing with the 8.
So yeah, so instead of -2, it's going to be what? -1. So this will be to the first power. So 2 times 4 to the first power. That's
Okay.
it. Any more questions? Ooh. All right. The next one is what, 70? Kathleen, did you get this far?
I did not get that far. I was working on the other one.
You think you can walk me through it?
Mm,
All right, so I know y equals CA to the x. So I think the easiest thing here to solve might be the C. So what is my C value here? So the C is coming from like your starting value or your y-intercept.
So would it be 3?
That's what?
Would it be 3?
I can
Oh, I'm
very,
sorry. Would it be 3?
yeah, that's it.
Okay.
So we know C is equal to 3. So fill in what you know. That's my advice on this one.
Okay.
Now we want to know, we use this point. There's basically 2 points I think we can grab off of this thing. Now we want to know what A is. We want to fill out C, we want to fill out A, so that all we have in our equation is just Y's and X's. We want to know what A is. I know that one of the points is 1, 1. How can I use that information to figure out what my A is? A little face creeping over the problem. So what should I do with those?
Plug those points, maybe.
Yeah, plug it in. So if I plug in 1 and I plug in 1,
1, yes.
can we solve for A? It's Kathleen.
Sorry.
Can you solve for A there?
I'm not sure. Would it just be 1?
So 1 is equal to 3 times A, right?
Mm-hmm.
We want to get A by itself.
Oh, so you divide by 3.
Yeah. So A is equal to what?
3?
No, the other way.
What? Oh, it's 1.
1 over. Almost there. That's it.
Okay.
All right. So we know A is 1/3. We know C is 3. We plug that in. already. So what is my formula if I want to write it all out with my C's and my A's plugged in? Y is equal to?
So it'd be 3 times 1/3 with
Yep.
the x on the top.
1/3 to the x power. That's it.
Okay.
Okay.
I have a question.
Yeah.
Does it matter? Okay, like how you have 1/3 in parentheses and you have the X on the inside. Does it matter if the X on the inside of parentheses or outside of the parentheses?
Oh, so whether I do 1/3 to the x and whether I put it like inside or outside the parentheses, those are both saying the same thing.
Okay, I was just trying to make sure.
I'm just trying to make sure, like when I do this, that like when I put the 3 out there, that people aren't confusing like that to be some mixed fraction or something like 3 1/3 or something. I don't know.
Okay, got
Yeah, I don't want people to mix that up. Don't do that. Don't do mixed fractions at this point in your life. Y'all are old enough. Maybe if you have to give your boss an answer like that or something, but like in math class, we pretty much try to avoid that. It's bad notation. All right, so that was what, 70? Are there any more questions on this before I clear it? All right. $75 assigned. This was assigned. Who else is here? Jerry, did you get this one?
75.
I guess we can
No,
read through 'em.
but we can do them.
Yeah, let's read through them right quick. Balance in an account after X years earning 10% interest compounded continuously. Ooh. Balance in an account after X years earning 5% compounded annually. Air pressure in a tire with a large hole in it after X minutes. Air pressure in a car tire with a pinhole in it after X minutes. What?
3 is 3A. Like just 1, 2, 3. Go with letter A.
Wait, now I gotta reread these. Compounded continuously. This is compounded annually. A large hole after, yeah, because those would be going down.
Yes, for this one, I want to say this too.
Hmm.
Four BC.
I think they're saying this. Yeah, this is kind of confusing. Because we're gonna lose a lot of air at first, and then it's gonna quit losing air. Because these are definitely the two that are decreasing. These two are definitely increasing, right?
Yeah.
It's I believe a pinhole is just gonna go down really slowly, right? Is what this is saying. Ooh, that is a little confusing. The big hole, it's gonna lose a lot of air to begin with. And then there's not gonna be so much air left in the tire to lose, I think is what it's saying. And then a pinhole is just gonna go down really gradually.
And then with the 1BB and then 2BD.
Yeah, so I would definitely say that something compounded continuously at 10%. I hope what you notice is that this one is going to be faster and this one's going to be slower, right?
Yeah.
I'm hoping the information that you're taking away. And if we do that, this one's growing slower. So I believe you said this one was D and that this one was what, B?
Yes.
So 75, the first one, part I should be what? Let me just make sure I got them right. Part I should be D, part 2 should be, did I say that right? No, part I should be B, part 2. I should be B, D.
Slow down, please.
One should be
Mhm.
B, 2 should be D. 3 should be A and 4 should be C.
Here, C, this is like it's stable, right?
C is like a pinhole,
Yeah.
and so you're just gonna lose a little bit of air at a time. Whereas like A is like there's a big hole. So when you have a big hole, it's gonna lose a lot of pressure in your tire. And then after that, there's not so much pressure in your tire, so it's gonna leak out a little bit slower. Kind of like when you got a flat tire, it'll always maintain that little bit of air in there usually. I think that's what it's saying here. You might be next to nothing in air, right? It might just be like a little pocket of air, but there'll always be a little bit probably. Okay, and then when the balance grows, these are both sort of exponential growth. But this one is the faster growth. This one's the slower growth. And 79. So who left? Fernanda, did you get this one? Vanessa, did you get this one?
I didn't
Amen.
get this far.
Okay. Do we remember graph transformations? I guess is the other question. That's the one that's like, I think always gets people. And it's been a few nights since we did graph transformations. I know y'all slept on it. Okay, so we're starting out with this base function 2 to the x. If we look at something like this versus happening to something like this, I want to know whether this graph transformation is going to happen to my x values or my y values. So if I look at something like A, I see a 2 to the x, but I see this transformation -2. Is that going to happen to my x value or my y value?
Would it be your X value?
No, your Y value, because it's going down with -2, is reflected down.
So our
Shift to.
the thing that we're looking at is 2 to the x. That's my base function. Is it happening within this 2 to the x, that transformation? Or is it happening on the outside, like somewhere over here?
It's happening on the outside.
It's happening on the outside. And if it's happening on the outside, that's happening to my
Why?
y values. So this transformation should be affecting my y values. Versus something like this, I see a -1. Is that on the inside or outside?
On the inside.
It's happening right here on the inside. We're throwing a -1 on the inside of this 2 to the x. And if that happens on the inside, that's happening to my
X.
okay. So being able to see whether it's on the inside of that function or the outside, whether we're throwing it on the x up in here in the exponent, or whether we're doing it like out here on the outside, that's going to determine whether it's like affecting my x or my y values. So if I see my y values and I'm subtracting 2, what is that going to do to my y value?
Would it make it go down to?
Down 2, exactly. So we're going down 2 units. What if I have a -1 on my x values? What does that do to my x values?
So go down one, right?
So if I subtract 1 from my x values, is that going left or right? Should be the question.
You're going right.
Right.
It's going right. So you subtract 1 sounds like it should go left, and x values are always backwards from what you think they are. So we're going right 1 unit.
You mean here, teacher, please. We are in the we are in the 79, right?
Yeah, we're doing 79.
Yes. Okay. I am looking for the C where we have 2 and 2 of the power of minus x.
Oh, I haven't gotten there yet. I was doing these two.
Okay, good. Because I'm scared if you are there and then I didn't understand. Okay, no, sorry.
All right, so if we wanted to graph these, I'm going to graph them really rough right quick. We're going to move it down 2 units. It's going to look something like this, right? This thing moved down. Ooh, I can't draw straight with the mouse apparently. Or I can't draw crooked with the mouse. And so maybe to notice like the asymptote's not going to be at 0 anymore. It's going to be right here at the -2. We're never going to cross this -2 line. This thing's going to shoot up to infinity real quick right here, right? So I'm taking that graph, I'm moving it down 2. The other one is moving what, right 1? So my asymptote's still going to be at the 0, but everything's going to get moved basically to the right 1. Ooh, keep hitting the wrong thing. I want to draw now. So right here, somewhere along here, everything gets moved to the right 1. Okay. Now I want to look at 2 to the minus x. Is that happening to my x values or my y values? What is happening? If I look at 2 to the x, how do I get 2 to the minus x?
I think it's to the x values and then it's the negative down.
Yeah, so I got to throw the negative on the inside of this function. So it's happening to my x values.
Okay, because I'm just guessing. Okay, thank you.
And what does the negative do?
It's going down.
Doesn't bring it up or down.
It's going right.
It's gonna what?
Oh, flip,
It's a negative factor, right?
flip it.
Yeah, those are flips. So we're flipping the x values. So everything on the right is going to go on the left, and everything on the left is going to go on the right. So this should be a flip of my x values. Or another way to say that is it's a flip about the y-axis, right?
Flip.
Did we do both flips? I don't know.
Oh.
I feel like we did. What is this going to do?
I'm not sure, but would it flip it
Flip.
down?
Flip
Flip
it
across the X.
across the x. Yeah, so now we're taking this to the x function. We're not doing anything to this function itself, but we're coming on the outside of this function, sort of, right? And we're multiplying this by a -1. So this is happening to my y values. So my y values get flipped. And if I flip my y values, they're flipping about the x-axis. So let's go with purple and draw this one. So now instead of this line coming that way, all my y's get flipped. And so I believe that line should look something like that, right? So flipping about the x-axis. Okay, questions about this? So if they're doing something up in the exponent, right? and it's like attached to the x, that should be happening to your x value. If they're doing something on the outside and we can circle this 2 to the x, if you can circle the 2 to the x and it's like your parent function, they're doing something on the outside of it, that should be happening to your y value. And you got to remember, I guess, your graph transformation. It's been a few days. All right, so we got 93. We're going to start around 93, 96, I believe is the problem. I want to try to get through 96, 103, and 109 next. So I'm going to try to piece them together through 3. So 96, you might have to go back and look at those formulas that were in your notes to get these. These are the compound interest formulas. 96, 103, and 109. 103, so 96 and 103 are both from this list. 109 is a bacteria growth problem. If you got those first few that we're going through, this might just come as like doing one more thing, throwing in a number in there and estimating it. Any questions before we go back to rooms? I'm going to open up rooms. I didn't resume it. Okay. If this thing says compounded continuously, we're going to throw it into the PERT formula. The PERT formula, does anybody know what that is? Probably not, because it's a trade secret. They don't like anybody to reproduce their shampoo. Does anybody know what PERT shampoo is? Yeah, I'm seeing some head nods. Yes, no. It's really weird. Like I thought it was like one of those things that's like really common, and then like I asked this like, I don't know, 2 or 3 years ago when I started teaching this stuff. And like people just didn't know it. PERT is a shampoo. It's still around. PERT Plus, I think is what they call it now. Anyway, it'll make your hair continuously clean. Questions about this? If it's compounded continuously, we throw it into the PERT formula. And so the last one I had y'all do was this, what, 109. All right, so let me white out this stuff right quick. All right, so if I want to find bacterial growth, we talked a little bit about this, but C is like my starting amount. A is the amount it increases or decreases. The rate of increase or decrease is my A. C is starting amount. So find an exponential model. B that calculates the concentration after X weeks. So I think they're saying maybe instead of Y, I want to do a B of X variable. And so I want to do B of X equals C, A to the X, right? Is the sort of way this thing should look. So a sample bacteria taken from a river has an initial concentration of 2.5 million bacteria per milliliter, and its concentration triples each week. So why is it important to learn exponential functions? Probably something like this, right? Bacteria, viruses, these things all sort of grow exponentially. Human populations, these things all sort of have exponential growth, right? These 2 bunnies have 2 bunnies, and then those 2 bunnies have 2 bunnies, and then those 2 bunnies have 2 bunnies. They grow exponentially. And we even use that word exponential to mean things that grow rapidly, right? We like sometimes people apply that word to things that aren't really exponential. And the more it grows, the more it grows, right? Is sort of the property exponential. The worse you let it get, the worse it's going to get. Sometimes we're talking about diseases or something like that. I'm sure that's not applicable to today's world at all. Find exponential model B of X that calculates concentration after X weeks. What is my starting amount?
Principal.
Is what?
It's your principal first.
Yeah, so we're doing the starting amount. My C is what number?
Would it be 2.5 million?
Yeah, so
Yes.
2.5 million. If you say, does it say anywhere? Maybe if we just say that this is in millions, we don't have to put the millions in there. So it depends how you define your function. If you want to let this be the bacteria population in millions, that's probably what I would do. It doesn't say anywhere on here whether or not. So let's just do, this is in millions, this is in millions. What is my A? How much does this shrink or grow?
Triple.
3. It triples.
Triples. Three.
So triples would be 3. One last thing.
The time is X.
3 to the X. Yep. So this is my function, my model to find bacteria. And it's going to find bacteria in millions. So estimate the concentration after 1.5 weeks.
Like, yeah.
And our X was in weeks, right? So maybe we also want to say that the X is the number of weeks.
Just to upload the X, the
We're over
number.
on time, just so you know. We're 4 minutes over.
Okay. You'll finish this off then. So X is the number of weeks. So we're plugging in, what'd you say?
Like the number of weeks, one point something to the 3. Like 3 powers of this number.
3 power of a fractional power. Yeah. So definitely doing this in
Yeah.
my calculator. So 3 to the 1.5. And then we multiply that by what? 2.5?
Yes, million. Yeah,
You should be getting something like 12.99.
it's 13.
There's about 13 million bacteria there. Yep. I will tell you this, there's 3 other word problems that we didn't go through, but they're gonna have you plug things into the exponent, right? We don't know logarithms, so there's really only one sort of way we can ask you to plug things in. So that you're probably plugging things into the X and not to the Y and back solving them. That is the end of class. That's all we got time for. If y'all have questions, stop the